In this video, we'll discuss triangle congruence. So when we talk about congruence, we're talking about identical shapes. They have to have the same angle measures and same side measurements. And all we're doing is transforming them by rotations, reflections, and translations. So here is an arrow as a shape. If I take and I shift it downward, it's still the same shape. They are two congruent shapes. I can even rotate it and move it again, and they're still identical shapes because they have the same angles and the same side measurements. Now we're going to use this idea of congruence to talk about triangles. And we're going to talk about oblique triangles or non-right triangles because right triangles have their own distinctions. Here we have four methods we can use: side, 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 angle, angle, side, and angle, side, angle. And we're going to look at those each individually. The big thing is when we state triangle congruence, we want to mark up our pictures and make sure we can determine which of these four methods make two triangles congruent if they are congruent. And when we write them and we state a triangle, we want to make sure that the corresponding parts are matching in our statements as what matches with our triangle image. So say that we want to start with side, side, side. This means that in each of the two triangles, the corresponding sides are all going to have markings of congruence with one of their corresponding side. So when I look at these two triangles, triangle CDB to triangle GEF, they're marked as congruent by side, side, side. And we can see CD is congruent to EG, DB is congruent to EF, and CB is congruent to GF. And that matches with what we say here: CD, GE, DB, EF, GF, CB. And if we rotate and flip it, we can see they are congruent triangles. Now the other method, side, angle, side. Here we're provided two corresponding sides that have congruence and the included angle. In other words, the angle in between the two sides. They have to be the included angle for the two triangles to be congruent. So say here we have triangle GEF and triangle LHK. And we can see we've got that side, angle, side. Well, where do we start? With that idea that we have this side and this side congruent, FE and KH congruent, and then we have those angles marked as congruent as well. And if I move it over, I can see, yes, they do align to give me two congruent triangles. Our third method would be angle, side, angle. In this case, we have the two angles of two triangles marked as congruent that are corresponding, and it's the side that's in between those two angles that's the corresponding side that's marked as congruent as well. So say we have, in this case, we have our two sides and two angle, or our corresponding sides and the two corresponding sets of angles marked here for this image. And you can see how those lines cross. They're crossing in the same way that are going to create the two congruent triangles. So let's fill in those dotted lines, and we can now see that HPW matches with NLV. And then if we rotate it and flip it over, we can see, yeah, they do align. And the fourth method is angle, angle, side. Here we have two corresponding sets of congruent angles, and then one of the two non-included sides are marked as congruent as well. So if we want to look at this image, here we have side DR and side MK that are congruent to each other, and we can see we have these other two angles that are marked as congruent. And by doing so, you can see how those triangles are being formed, that they have to be congruent for those two angles to be congruent as well. So automatically we can draw in those sides and say, yes, RDQ and KMP are congruent triangles by angle, angle, side. And you can even rotate and align the pieces to see what is matching up, and that matches with how we stated those two triangles. Now let's look at an example of how we can use triangle congruence to help us prove other properties of triangles. In this case, we're trying to show that triangle ABC, the larger triangle in this image, is isosceles if we know that segment BD is perpendicular to segment AC, and we know that segment BD is an angle bisector of angle ABC. So when we have a problem like this, we need to take it a step at a time, and we can use the congruent triangles, prove that they exist, and then use their properties to look at the larger piece of what we're trying to do here. So let's start with what we know. We know that we have perpendicular angles and the angle bisector. So we mark those angles, and that's the first thing we want to make a statement about when we're going to write out why this is the case. We're not starting with what we're trying to show. That's where we end. We start with what we know. And what we know is that since BD is a perpendicular to AC, that angles have to be congruent. And we know that since it's an angle bisector of angle ABC, we know these two angles must be congruent. Now to get to triangle congruence, we need three pieces. Since we have two angles, we need something about a side. Well, there are no statements up here, so we look at our image and say, are there other pieces that may be helpful? And in this case, what we have here is a shared side. And we can then use that and mark it as congruent and say, oh, that's how we're getting to our two congruent triangles. So our next statement is going to be that since BD is a shared side, by the reflexive property, it has to be congruent to itself. Now we have a method that we can use, and we have two smaller triangles that are congruent here. And we're going to say, well, what's the reason? Well, we have angle, side, angle. So by ASA, we can say that triangle ADB is congruent to triangle CDB. And then what that does is it allows us to mark all the corresponding parts as congruent. And that helps us then recognize, well, what's going on? Because we're looking at the large triangle ABC. So we need to say, okay, well, what do we know from our congruence? We know that since those parts are congruent, AB has to be congruent to BC. And now that we know they're congruent, look at the big triangle. Oh, that's two sides of the large triangle. They're marked as congruent, and since that's part of the definition of being isosceles, we know that triangle ABC must be an isosceles triangle.